So welcome to day 4 of camp, Civil Engineering Day. There are a little bit less people today, but that's just because some of you have gone to school. So hopefully you'll be watching this webinar. Shout out to you. Again, if you have any issues tonight, guys, with not being at camp, or if you are at camp and you have any issues with the activity or challenges, join the help desk at 5 to 6 p.m. Eastern Standard Time. But let's get started. So can you hear me? Can you see me? I think you can because we've been working out these things, but make sure you have your workbook in front of you, your supply list, and your parent nearby. All of your screen names have been changed to the correct ones. So for anyone who hasn't been here throughout the week, any new people, the reason I've done this project, this is my Gold Award project for Girl Scouts. I've decided to host a camp for you guys, 4th to 8th grade girls, to empower them to be future women engineers, hopefully, or let them get to know the basics around a few engineerings, the main core 4 plus aerospace and a few more tomorrow on Friday. But I decided to do a camp for girls, a 5-day camp, and I chose to do that because when I was touring colleges, I was having a little bit of an issue finding role models to look up to. So in this camp, I have role models for you each day to look up to, ask questions to, and for them to present to you what it's like having a day-to-day job and what it's like for the college experience with a college role model to look up to. So today is civil engineering. Speaking of civil engineering, here is my civil engineering shirt. It's the periodic table of Minecraft. So the reason I chose this shirt was because in civil engineering, they have to make sure that they have to look through materials, look at the land that they might be building on, just kind of survey the land, make sure that the building won't collapse because the soil's too soft or anything. So they got to make sure they check over materials before they start their build. So that's why I chose this shirt. But yeah, again, today is Civil Engineering Day. So I'm going to introduce you to Chase. Chase is our chat moderator and prize patrol for today because, yeah, I need a prize patrol for someone to spin the wheel, and I need someone in the chat to make sure you guys are putting your comments in the chat and your questions in the Q&A. So she'll be helping with that. So Chase is a senior in high school and in her final year of Girl Scouts. She has been a Girl Scout for 13 years, and she enjoys horticultural and agricultural biology. She also enjoys hiking, and she plans to major in psychology. She's another STEM girl. So let's move on to the slideshow of people who posted last night. Here it is. So here's the slideshow that I made this morning for all of your all of your challenges. So here is Gabby. She was very committed to making different paper airplanes during the session. I see that she has made her launcher too, along with the paper airplanes, that she's also decorated one of them. And here's her again, and her safety glasses doing her paper airplane that we did yesterday live. And here's her again doing that. And here is Margie. Here's a picture snapshot of the origami rocket. For me, I made mine a little bit smaller than yours so that it could go higher. So that was my little improvement for the challenge. Here's Emily's. She decorated it, and I think it looks pretty cool, and it's blue, which is my favorite color. And then here's her launcher and her paper airplane in the launcher. And here's another video. These are Ruby's videos. So here's one of them. He did a flip. And then here's the other one. And again, if you didn't fully complete the improvements for your challenges, you can always keep continuing them night to night. Like tonight, once you finish your challenges for tonight, you can also go back to other days. Oh, that one went pretty further. That one went further than the last one. So that is the slideshow. But so again, for the challenges, you can keep continuing them night to night. What is something I should have you guys do? So put in the chat what your favorite challenge has been so far this week. I think mine was the, I really like the strawberry, the DNA from strawberries, but I also really liked the, oh, Ruby says she likes mechanical. Christina says I like the airplane and the launcher. I'm glad you like that. I found the launcher and I thought it was really cool. Gripper, oh, the grabber and the other one. So the grabber and the catapult. Yeah, Emma also likes the catapult. Zofia likes the strawberry DNA. I thought that was pretty cool how it came out in this goop. Miriam likes the catapult. Annabelle, she liked the rocket, the origami rocket. Yeah, I like that one too. It's pretty easy to fold, and I liked how cool that we turned the straw into the like the launching of the rocket, which is pretty cool. So how about I say a few things that I grabbed from the registration when you guys signed up? So Niffler loves science and creating things. Well, so I think this is the perfect camp for Niffler. Niffler was their screening that they chose. I'm not sure if they still chose that or if it's now their name, but Niffler loved math, science, and creating things. We have a lot of STEM girls in camp that love to build, including also Hayden C., who likes building things using whatever she finds around the house. Sounds like me. I would scrounge through my craft section of my basement and I'd grab all these craft supplies and I build whatever I think of. Like I just kept doing it and doing it. My mom wasn't pretty happy though, because I'd always leave a mess behind after doing my fun little experiments and building things. Kayla B loves to build and design houses for her Barbies. Sounds like a civil engineer to me. This is a perfect day for you. I just go through the recycling bin. Yeah, I mean, that's a pretty good idea. You find a lot of cardboard and bottles and stuff. Oh, UJ likes all of the challenges. She can't pick one. So I also see that UJ says her sister says she built a catapult with Legos, and I don't know what it is. Well, so I remember there's these like Lego camps out there, but I've heard that well, not really I heard that. I think that if you start out with Legos is like the beginning of being a civil engineer because you're building up, you're building towers, you're building buildings. Some people, they buy the Lego sets and build the Death Star or they build the White House. There's a lot of things to build. I think Legos is the beginning of civil engineering, just the start, like the kid version of it. No, a putt-a-pult. My sister is only 3. I have no idea what a putt-a-pult is. Maybe it's something to launch a golf ball, like putt-putt or something. I'm not sure, but that sounds very interesting. So let's move on. We just did the prize wheel. Let's do some review from throughout the week. For those of you who weren't here, I'll explain it a little bit, but here's what we've been doing throughout the week. On day 1, we went through chemical and chemical engineering and engineering in general. Here is the engineering. So we have a core 4 for engineering, and the core 4 are civil, mechanical, chemical, and electrical. Today we are going over civil, but the reason that there are these core 4 is because these are the 4 engineerings that everything else branches off of. So for civil, there's a few different like topics that it branches off of. Some people focus on building things in the ocean, like those tunnels that you drive through. Like I drive through an underground tunnel when I go to the beach every year. We like to hold our breath when running under it, when going under it. For chemical engineering, there's polymer engineering, where they focus on making polymers and stuff. There's also a few other ones, but I can't remember at the moment. But for mechanical engineering, what we went over yesterday was aerospace and aeronautical. Those branch off of mechanical engineering. But the reason these are the core 4 is these are the 4 main topics that all the other engineering branch off of. So with civil, there's a bunch that branch off of it that are more focused on different topics, like transportation is one. There's also ones that focus on like buildings. It looks like a tower though for some reason. Well, if you find any more about your putt-a-pult, then let me know. But electrical, there's also some that branch off of that one, including telecommunication or circuits or like electronics, but there's a bunch that branch off of them. So those are the core 4. After that, we went over some keywords for engineering, including solutions, math, science, technology. Again, how engineering is part of STEM while it also uses STEM, because science, technology, engineering, and math. So it's part of it while also using it. But engineers are also problem solvers, inventors. They make solutions, they use math, and those are all of the key words for engineering. We also went over the key words for chemical engineering, which are processes, reactions, chemicals, raw materials, products, manufacturing, optimization. Optimization is where you make something work the best, be the best it can be. It's just optimizing it is making it the best. So they get raw materials and optimize them and make products out of the raw materials. So that is the keywords for chemical engineering. There's also the keywords for mechanical engineering, which we went over on day 2, which are machines, including power using and power producing machines. The power using machines, they use power. For example, a fridge, it uses power to work, but a power producing machine includes a generator, which creates power to power your house. If you ever have a power outage during a storm, you plug in that generator, generates power, and gives your house some juice to work. And there's also hydraulics, gears, and like cranks, tensions, lever, which they use to create the machines. But there's also movement. Movement, we made one of the keywords because all of these machines and things that mechanical engineers, they have movement within them, where there's gears spinning, things moving, things pulling within the mechanisms and machines. So that's mechanical engineering. And then there's our aeronautical and aerospace engineering with weight, thrust, drag, and lift, where weight is a force that's always acting upon it, while thrust, weight, and thrust, lift, and drag are the 3 forces that act upon it whenever it's moving. Like whenever it's moving, there's the wind that's dragging it back. There's the fuel that's thrusting it forward. And there's lift because of the wings. They're built correctly so that when the air flows over them, it actually lifts up the plane. So without wings, I don't think a jet or a airplane would work. So I think the wings bring you lift. The air brings you drag, and the fuel, which powers it, brings you thrust to thrust it forward. So that is aeronautical engineering and aerospace, where aeronautical is focused on everything within the atmosphere, and aerospace focuses on not only within, but also outside of the atmosphere, within space, like rocket ships and stuff, but also in the atmosphere, like jets and airplanes. We also went over the engineering process, which I chose this one for this week because there's a few different kinds, but this one I like the best because first you got to identify your problem and explore the possibilities and different options for what you're building. And then you go into the trial and error design process where you design something, you create it, you try it out, and then you see if you need improvements. And if you improve it, you design it again, create, and try it out again. So that's the trial and error process after the identifying the problem and exploring possibilities. So that's why I chose that engineering. But again, first attempt in learning, not a lot of people get their things on their first try. So that's why improve is in the engineering process, because you never get on your first try. So there needs to be a cycle of trial and error until you get the best you can get. Optimizing your build, like say I was building an airplane, I may have to make a paper model. And then once I go off that, if I want to improve it, I may go to a better material or to a better one or to a better one, but I would be doing trial and error, making the best it can be, improving it. So there was that. Now on to today. So today is civil engineering. We've already gone over chemical, mechanical, aerospace, and aeronautical, and now we're on to civil engineering. So let's do a quick poll to see how much you guys know already about civil engineering. So let me pull that up really quick. So how much do you know about civil engineering? Even though some of you guys started school today, there's still a lot of you guys here. But that's really great. But yeah, again, if you aren't here and you're watching this recording later on, just know that the help desk is at 5 p.m. to 6 p.m. tonight. Tonight is Thursday night, so you can join that and get any help on the challenges or just review on anything. I can help you out tonight at 5 to 6 p.m. So 20 out of 25 of you have filled it in now 21 of you. If the 4 of you who haven't filled it out yet, if you're having any issues, you can put your answer in the chat, either how much do you know about civil engineering, a lot, a bit, not much, or nothing. But I'll end this in a few seconds. Okay, 3 more to go. Okay, I'll just end that here. So here's the results. So one of you know a lot, which is pretty cool, but a majority of you know a bit, which is actually half of you guys. Not much. Some of you know not much, and some of you know nothing, but that's totally fine because we're going to change that today. We're going to tell you a bit about civil engineering. So let me stop sharing that poll. Pull that away. So now we're on to civil engineering day 4. So let me get that the workbook shared again really quickly. And while we're doing that, I'm gonna check through all the names again, make sure they're all done. Okay, I have to change one. Okay, we're all good. Okay, so civil engineering day 4. So everybody, make sure you have a pencil or pen in front of you and your workbook. If you don't, then you can just watch this and we will be posting the filled in one later. So next slide. Okay, so pull out your pencil or pen and we will fill this out right now. So this is, for any of you who haven't been here yet, this is our little definition page. We have one for each day, which we have posted on the Facebook page. If you're not on the Facebook page, you can always have your parents email me, but let's get started on this definition page. So civil engineers solve problems using their knowledge of physical and natural equipment. Oh, let me restart that. Words are not good right now. So civil engineers solve problems using their knowledge of physical and natural environments to develop solutions. They design construction. Words not good today. So they design, construct, supervise, and maintain man-made and naturally built environments, including buildings, bridges, tech issue. Can we restart that? So they design, construct, supervise, and maintain man-made and naturally built environments, including buildings, bridges, roads, canals, dams, airports, sewage systems, pipelines, railways, etc. So the 3 blanks are bridges, buildings, bridges, and roads. On to the next one. So civil engineers use specialized tools for surveying sites and creating blueprints like geographic information tools, compasses, grade rods, chains, and tapes, prisms, and reflectors. So they survey the land to make sure that it's the right type of soil so that their building won't sink in over time. And they survey it just to make sure it's the right place for them to be building what they're building. So they survey the land and sites. They also use specialized tools for testing construction materials, soil, and water. They supervise construction using large machines to build structures using steel, concrete, timber, and other strong materials. Civil engineering has been around since the first person put a roof over their head. So I think this is the earliest engineering, because like when you're out in the wild and you don't have anything in front of you, you got to build shelter first. So civil engineers came into play when people started building shelters for themselves. So they're around since the first person put a roof over their head. So we click to the next page for the filled in one so you can look at it. But yeah, here's the blanks. If you haven't filled it out, you can fill it out really quickly. Or if you don't have your workbook in front of you, this page right here, will be on the Facebook group guides. So it will be there for you later on if you don't want to fill it out now, or if you aren't able to fill it out within this moment. So I'll give you a few seconds to fill that out. Is everyone ready to move on? Has everyone filled it in or seen it enough if they're going to fill it out later? Okay, so I've gotten a yes. Okay, so there's 2 hands raised, so I'm going to wait a second. Again, lower your hand when you are finished, and then we will move on to the next slide. Still got 1 more hand raised, so I'll be waiting for a moment. But while we're waiting, I'd like to introduce you to someone. So today, we're not going to flip the page yet. We're going to leave this up for a second. Okay, so everyone's hands are down so we can move on, actually. So I want to introduce you guys to Nicole Abramson. So Nicole is a civil engineer at the National Institute of Standards and Technologies. She works in the Design and Construction Division, where she oversees construction projects. Prior to working at NIST, she worked as a project manager at Clark Construction in Southern California. She also studied civil engineering at Virginia Tech, where she earned her bachelor's and master's degree. So I'll hand it over to Nicole if you wanted to add anything about the last page or expand on it, or just present your presentation for us. I'll hand it over to you.
I will go ahead and get my presentation set up now.
Okay.
All right, are you guys able to see my screen?
I can see it.
Okay, so today I'm going to share a little bit about my experiences with you guys and teach you a little bit more about civil engineering. So like Ruby said, I'm an engineer at the National Institute of Standards and Technology, or NIST. It's a large research campus that's in Gaithersburg, right off of 270. And I went to Virginia Tech, where I studied civil engineering and got both my bachelor's and my master's in civil engineering. And for my master's, I focused on environmental and water resources, which is one of the civil engineering disciplines that I'll tell you guys a little bit more about later in my presentation. So we've already seen this definition on Ruby's slides. Civil engineering deals with the design, construction, and maintenance of roads, bridges, airports, and buildings. So wanted to get started with just telling you a little bit about my civil engineering career path and how I got to where I currently am. So when I was in college, I had several different internships, which is where I would go work at different companies for a couple months each summer. I would get to do different tasks to help out the other full-time engineers and project managers, and also just learn a little bit more about the different companies and help me figure out what I wanted to do after college. One of my first internships actually was not at all related to civil engineering. I calibrated instruments for small-scale submarine models, which was a pretty cool internship, but wasn't quite what I wanted to do. So I kept getting different internships to figure out where exactly I wanted to go. After that, I worked at a paper mill. I managed some small projects around $10,000 or less, all around the paper mill, and also was part of a safety committee. We spent the week investigating all the different equipment and different processes that they use to make the paper. And we're brainstorming and talking about ways that we could make some changes that would help the people work a little bit safer. And then next, the picture on the right, this is a high school in Southern Virginia that I worked on. There were 2 different high schools in neighboring communities that were being built, and I worked for the company that was the owner's rep. So our job was to oversee all the construction and report back to the owner, the people that were building the schools, to let them know how the progress was going and keep track of all the documents and make sure everything was in order. And one of my jobs, that was my favorite job, is I go around the site taking pictures of the different workers and writing down what they were working on, and then post on the community website some updates. A lot of people were really excited for the new high schools. They were excited to go to these nice new schools. So everyone in the community wanted to know when they were going to be done and how much longer the construction was going to be. And one of my last internships, one of the key words was surveying. So I spent a couple of weeks out in Northern Virginia. There was this future community we were working on. So I used survey equipment to measure out the future home sites. So the different plots of land where people's homes were going to be built. And then used a computer program where we updated the drawings to show where the houses were going to go, the sidewalks, the roads, all the different parts of the community. We would have those drawn out in the computer program that's called AutoCAD. Towards the end of college, I got to do something that was really cool and definitely helped me really be sure about civil engineering as the career path for me. I spent a month, 2 different summers in Punta Cana. That's an island. It's on the Dominican Republic, which Haiti and the Dominican Republic, they share an island. And while we were there, we focused on water resources and also transportation engineering. For the water resources part, we would go around the neighborhoods and we would take water samples. There was a bunch of people that had water tanks up on their roofs that they would pump water out of the wells. And some of the water samples were not clean. Some of them were contaminated. So we would share that information with the residents so they would know if they needed to be purchasing water off the water trucks that came around each week to the neighborhoods. And for my master's, I did some research and we came up with what we think that the path the water was traveling underground in the water table, how the water and the contaminants were moving around the water table. And then the 2 pictures on the right, those were from the Punta Cana International Airport. It was pretty cool. We got to spend some time at the control tower of the airport and also down right by the runway watching the planes, which was pretty awesome. There were some golf courses and different hotels around the airport that were concerned that the airplanes taking off were being really loud. So my group spent the day at the golf course where we recorded the noise measurements for the different airplanes. So we could let the golf course and the airports know what type of noise was being produced. And we also, from the control tower, we were measuring how long the different planes were taking to taxi. So how long they were driving around the runway before they were taking off. And then after college, I worked as a project manager for a general contractor. A general contractor is a company that oversees the construction projects. So this was when I was in Southern California. When I was there, I worked on developing cost estimates for all different types of projects. There were high schools, prisons, college dorms, and different college buildings, and even amusement parks. And part of the job there, I was awarding the contracts for the companies that were going to be purchasing the different materials and then using them to build the buildings. So we'd work with the companies that were going to be installing the drywall or the steel, landscaping, and much more. Everything that would go into the building, we'd have to write a contract so someone could purchase that material and then install it for us. And I also managed contractors on construction projects. So I would make sure that we knew how much their work was costing, that they were doing their work safely, and they would be proposing different materials that they wanted to install. And I would have to make sure that what they said they wanted to install would meet the requirements of the project and that everything was going to work okay. And that brings me to my current job. I'm an engineer at NIST. Just like when I was working at the last company, I'm also developing cost estimates and managing construction projects. Some of these projects include sidewalk repairs, road paving, rehabilitation, and repairs to the brick that's on the outside of some of the buildings. And as part of the job, I get to visit a bunch of different construction projects around campus, take pictures, and talk to the contractors that are doing the work to see what they're working on and what they're going to be working on in the next couple days. Like Ruby said earlier, there's multiple different disciplines that make up civil engineering, and there's a lot of overlap between these, but these are the general disciplines, and I'll tell you a little bit more about each of those on the next slides. So first is structural engineering. If you ever see a big building that's being constructed and you see a crane lifting pieces of steel up onto the building, a structural engineer would have figured out how many pieces of steel, the length of the steel, how big the steel needed to be. They would have been involved in all of those things, and they would have even helped figure out what size crane was needed to lift those pieces of steel to build the buildings. And one thing, so structural engineers observe construction sites. So that's an overlap between construction projects and structural engineers. And next is geotech engineering. If you guys live in a house with a basement, a geotech engineer would have been involved. As the dirt is dug out to build the basement, the geotech engineer would have to make sure that the dirt wouldn't be falling back into the hole and that the walls of the basement are strong enough to support the weight of the dirt against it. Next is transportation engineering. So when I was in Punta Cana and we were working at the airport, that was part of transportation engineering. Transportation engineering is also involved in complex overpasses and exit ramps, like in this picture, and even just around your neighborhood, if you have stop signs or stoplights, all those things, a transportation engineer would be involved in planning and maintaining. Next is land development. Where I live in a neighborhood that has apartment buildings. There's some outlet shops. There's townhouses, there's condos, there's all different types of buildings in the neighborhood. So a land development engineer would have helped figure out where everything would be going, where we'd fit the houses and the townhouses, the layouts of the roads, and all that type of stuff. They also would be making sure that as it rains, we're not having any floods in the neighborhood. So there's some rain gardens and different areas where they planted more trees to help with the reforestation, since some of the trees have been taken down. So they're involved with every aspect of turning a piece of land into community, a park, whatever it may be. And next is environmental and water resources. So they deal with air, water, and soil. When I was in Punta Cana and we were collecting water samples and testing the samples to see if the water was clean or contaminated, those are the jobs of a water resources engineer. And last is construction management, which is what I do as part of my current job. It's the oversight from all the way from the beginning, from the planning of a project through the very end when the people are moving in to use their new building or the new roads and new bridges, anything like that. Construction management is involved throughout the entire project and overseeing all aspects of the construction. Are there any questions?
Yeah, so I heard a bunch of different types of like civil engineering. Which ones specifically have you had to like take classes or specifically take a course on in order to like fully fulfill your requirements within like your projects that you've been doing? Like which one of these have you specifically been a part of?
So at Virginia Tech, there was a certain number of classes that were in the different disciplines we needed to take. So I've actually taken a course in everything on this list except for geotechnical. I haven't taken a geotech course, but I took a couple of construction classes, a bunch of water classes since my master's was in water, and then a couple of land development, transportation, and structural courses. So in college, we got a really good understanding of the basics of all the different disciplines, which helped us figure out what we might want to do after we graduated.
Oh, so everything but geotech. That's pretty cool because like before this project, when I was making this camp, I only thought civil engineering was its own thing, and it was just its own little part of all of the engineering, but I didn't know all these things branched off of it, which is pretty cool. Okay, so here's a few questions that people have put in the Q&A. So what is your favorite project that you've done?
Hold on, I'm having issues with my screen. So my favorite project was probably when I was in Southern California. There was a really large college campus project we were working on. The overall project was $500 million, and it had, I think, 7 different buildings. There were some 13 and 14-story dorm buildings. There was a big academic building where some of the teachers had offices, and there were classrooms. There was a dining hall, and there was a lecture hall. But before we even started the project, I was sent down there with a couple other newer engineers, and we got to go around the campus and interview the college students. They were telling us like what they like about the campus, what things they'd like to see. So one of the things, they really liked this lawn area that was outside of their dorms. Like they would all hang out outside, and it was San Diego, so the weather was always really nice. So there was a lot of open areas, like grassy areas in the final design. And some of the dorms even have ocean views. So the buildings are super nice, and the kids that go there, I think they really like the campus. So that was a cool project.
It's really cool how you can just look at something and say, I was a part of making that. So that's really cool. Someone says, so these are basically like subcategories of civil engineering.
Yeah, these are all different disciplines of civil engineering. So they're all considered civil engineering, and your job may have different aspects of them. So there's a lot of overlap between the different jobs, just like the structural engineer. They do the design of the structural components, but then they also come out to the construction site and are watching the project be built to make sure that if they specified a certain size steel, that's what actually gets installed. So there's a lot of overlap between the different disciplines.
Gotcha. And so what was your favorite part of being a civil engineer? Not specifically the project, but like the roles that you played.
What you said earlier, I think it's super cool to be able to, after projects built, to drive by it and be like, I helped build that project. It's just really cool to see people using the project and know that you were a part of it.
Yeah, I would agree. If I ever built something big, it's cool to just look at it and say, I was a part of that. Someone else asked, how do you build a bridge without it falling or you getting hurt?
So I actually never been part of a bridge project, but they're definitely very complicated, and there's a lot of planning that goes into building a bridge. So from very early on, just when it's an idea, you'd have almost every one of these different types of disciplines involved, from structural to geotech, transportation, land development, water resources, and construction. All parts of this would be involved. So a lot of projects, they first use a 3D software like AutoCAD, or like different building information models, where they would draw out the bridge. So they figure out how it's going to be built, almost building it in 3D on the computer before you ever build it in real life. And as part of that, you would have the construction people being involved, figuring out how can we do this safely. And safety is definitely one of the most important parts of building a project. So there's a lot of planning that goes into it from the beginning to make sure it can be done safely. And that's how that 3D model helps to kind of figure out where are we going to have issues and how are we going to be able to build this.
Gotcha. So you use that 3D model to figure out the issues before they actually become an issue.
Exactly, because it's a lot easier to address in a 3D model when compared to in real life building the bridge.
Yeah. So Annabelle asked, did anyone ever tell you to stop or that you weren't good enough to do civil engineering? Let me expand upon that. Have you ever felt that like you made a mistake, or haven't ever done anything wrong within your career that you felt you should back away from it? Like, what thoughts did you have that brought you back to keep going forward?
So ever since I was pretty little, like probably around elementary or middle school, I've always liked science and math classes. And my dad, he's retired now, but he was an engineer. So I always thought, I like science and math. I think engineering would be good for me. And it's something my dad does, and his job was really cool. So pretty early on, I started to be involved in different engineering groups. There was a women in engineering group I was in high school. And in high school, I took some project lead the way classes, which were pretty much all guys except for 1 or 2 girls in the class. But the classes I thought were pretty interesting. So when it came time to apply to college, when I first started at Tech, it was actually pretty evenly split between the guys and girls freshman year. But over the years, the number of girls in my classes became less. Some people would change majors, decide that they didn't want to do engineering. But by the time we graduated, there was definitely a lot less girls than when I originally started. But I really liked college and all my internships. So I knew that I wanted to stick with engineering. And once I started work after college, it was kind of the same situation where when I started with a lot of other girls, but higher up in the company, there weren't a ton of girls. It was mostly guys that were in the upper leadership positions. So that was a little bit discouraging, but I went to some different conferences for women in construction and women in engineering, where I got to hear from different women that are higher up in companies and just network with different women within the organizations. So some of the time it has been challenging not seeing as many women at different levels, but I've always been really happy with my decision to be an engineer. And it's exciting to see other young girls interested in engineering. So hopefully we can keep having more girls go to college for engineering and continue to have there be more women in engineering.
That's cool how you're able to go to those different conferences with women in it and feel more empowered as a woman in civil engineering.
Yeah.
Somebody also asked, which is your favorite type of civil engineering? So which one of the like break-offs or subsets is your favorite to work within, or like just use within the daily life of being a civil engineer?
So as I was finishing my bachelor's, I wasn't really sure what type of civil engineering I wanted to do. I knew that I liked water resources and I knew that I liked construction, and I was trying to decide between the two. So I got my master's in water resources, and at the same time, I was having the internship at the construction company where we were building those two high schools. And I really loved working on the construction projects. There was a superintendent that would show me around, and when I started working at the project, it was just like a dirt field. There was nothing there. And by the time I was done, it was almost to finish high school. And I just really liked being out in the field, seeing the workers, seeing the progress every single day. So I decided that construction is what I wanted to focus on. And I've been really happy with that decision. I really like construction aspect of civil engineering.
It's cool that your job lets you be outdoors all the time, like just watching the projects and stuff.
Yeah, definitely. Some days I can spend, it depends on the day, but like the days I'm on campus walking around to all the different projects, I can spend a good bit of my time outside or going between the buildings, which is a nice change from sitting at your desk.
Yeah, it's very nice. I'm hoping I get a job that lets me be more hands-on than having a desk job.
Yeah.
So somebody else asked, what is your favorite building to help make within your construction management area of civil engineering?
So the prison project, I worked on the estimate when we were working on getting that project. It was interesting just because there were so many things that I had never thought of when it comes to building a prison. Like the walls, to make the prison secure, the concrete walls were very, very thick. And there's just a lot of different things that went into the prison layout and how to make it secure and safe for everyone. So I got to see that project under construction, and there was so much concrete there. It was crazy how much concrete went into that building. So it was pretty cool just to see a different type of project that I'm not really used to seeing.
Yeah, I bet that sounds pretty interesting too. Like, was it because they were very thick because of all the precaution they had to take having it be a prison? Was that because?
Yeah. Yeah. So there was a lot of rebar, a lot of steel rebar that was in the walls. And then the walls were just really thick to make sure like you don't want anyone to be able to like break out of the prison. So
Yeah.
it's a lot of things that you never really think about until you're looking at like the construction drawings.
Yeah. So one more question. What does it take to become a civil engineer?
So to become, I think really any engineer, you if that's what you're interested in, I would say to go for it. You don't even need to know what type of engineer you want to be when you start college. If you think you want to do engineering, like at Virginia Tech, you start as a general engineer. Everyone starts as a general engineer for the first semester. And then after the first semester, you're able to declare what type of engineer you want to be. So when I first started, I thought I want to be a mechanical engineer, and like I was pretty certain that's what I wanted to do. But they made us go to these different info sessions where we would learn about like aerospace engineering, mechanical engineering, chemical engineering. We'd go to these presentations, and after the end of the civil engineering one, I called my dad and said, "Dad, civil engineering is really cool. I think I want to be a civil engineer. Is that a good idea?" And he said, "Of course, if that's what you want to do, go for it." So I declared my major that night of civil engineering. And then I went through the classes. Some of them were definitely harder than others. So I took advantage of like going to the office hours. So going to talk to my professor and getting help when I needed it, and working with other students in the class to do the homework, to study for the tests. And then definitely the internships were a huge help, not only to figure out what I wanted to do, but also figure out what I didn't want to do after college, to just learn about a bunch of different companies and what are the different opportunities out there for me. So anyone that's interested in engineering, I would definitely pursue it. And there's programs for all different age people. Like when I was in high school doing the Project Lead the Way classes, or the women in the Girls in Engineering group. There's different groups out there where you can kind of start to learn a little bit more about engineering and continue with that path if that's what you're interested in.
I like how they, well, at your college at least, I like how they made you take that engineering class, because you never really know what you want to do until you see it hands on, or just like get to know about it more. Because like, for me, I know that I like chemicals and stuff, but I will never actually know until I either get in the field with an internship or take the actual courses. So I like how they're having you do that, so you make sure that you like what you're doing, because if you like what you're doing, you never work a day in your life. So that's really cool.
Yeah, I would have ended up with, if I didn't have to go to those info sessions, they were mandatory. We had to go as part of our class grades. And if I didn't go, I would have not even considered civil engineering. So it was really good they made us do that.
Yeah, but for everyone that wants to be an engineer, just keep your possibilities open and be open to different possibilities, because as long as you know you want to be in engineering, you'll find something. So just keep your possibilities open and you'll find something that just grabs that niche that you love in life with engineering. Like for me, it's chemicals. And for Nicole, it's building things and construction management that she really liked a lot within civil engineering. So that's really cool how they give you that in college. So don't think that you need to know what you need to do, what you want to do now. Just be open for possibilities and you'll find something. So thank you for presenting and answering these questions, Nicole. It was really interesting, even for me. So thank you so much.
Thanks for having me.
So for everybody else, what was your favorite thing or favorite topic that Nicole talked about within her presentation? Okay, there we go. I fixed the spotlight thing. So yeah, what was your favorite part about Nicole's presentation? I think my favorite part might have been that she talked about how she made an amusement park and how she made that big college. Like, it's cool that she can literally look at something and say that she was a part of creating it. Annabelle says, I thought it was cool that she got to help build a prison. I think that's pretty cool too, and how she had to go through extra constraints and like things that needed to be done within the prison. UJ says all, so everything about that presentation. So let me pull up the crossword puzzle for you guys to then show you the keywords again, show you what we have for you for civil engineering. So it says, I was inspired by the fact that creations she had helped build made people happy. Yeah, it's really cool how she can make a difference with either giving someone a college to go to, or helping create an amusement park for people to have fun at. Miriam says the water is interesting. I would feel happy to help prevent someone from getting sick. Oh, from the water testing that Nicole had to do. So here's the crossword puzzle that we have made for you. Again, the red words are the ones that you're using to fill in this crossword puzzle. And you can fill it out whenever you want, anytime. And the answer key is in the bottom right corner, which you can scan with a phone. So this is a QR code. So I thought that was pretty cool. And we chose to have like little buildings as the picture for all the keywords. So let's discuss. Sorry. Let's discuss. So we have 3 questions for you for recap on civil engineering. And here are the questions. So what does a civil engineer do? What can a civil engineer create? And what special things do they know about? So if you have your workbook in front of you, you can fill that in right now and then put your answer in the chat. Or if you don't have the workbook in front of you, you can just put your answer in the chat. But this is just a kind of a recap so that if you say you are interested in civil engineering, but you may like this is that you remember the information more that you've learned throughout the day, and you can go back to look at it later on. So that's what this is here for. So fill out your answer either on the paper or in the chat, and I can call out a few that people put in. While you're doing that, let me grab a few more things from the registration that you guys put in. So Zofia P looks up to women in STEM, especially Brickmaster Amy Corbett, who she really admires. Lego is a great place to start for civil engineering. Like I said earlier, like you're building things in a smaller scale with bricks, like how you may build out like with actual real life bricks with building a building. So it's cool start for civil engineering with Legos. And Camilla M, her mom has a background in architecture, and Camilla M seems really interested in seeing the before and after of her mom's projects. So Nicole, how does architecture fit in with civil engineering, and are they similar or different?
So civil engineers and architects have to work really closely together for, so the big college campus project that I worked on, it was a design build project, which means that the architect company is teamed up with the construction company. And the university says we want to have a project that can have like 1,000 beds, that can have so many offices, can have this many seats in the dining hall. What design are you guys proposing to build? So with the architect, we worked really closely to figure out like what size the buildings needed to be, what the materials could be for the building. So on the outside of the building, if it should be plaster or if it should be brick or should it be siding, like what materials they should use. And even within the buildings, like what should be on the floors, what should be on the walls. Should there be carpet in the dorms or should the floors be like a concrete material? So we worked with the architect to figure out what we thought would be the best design and then also what would be able to fit within the budget. So we had to go back and forth and figure out what was most important for the design and then prioritize that when it came to the cost of the project. So pretty much every single day for the duration of the pursuit of the project, I was talking with the architect and they were asking me what different materials would cost or asking me to price different designs they had come up with. So they work very closely together through the design. And then once it comes to construction, the architect's involved in approving submittals. So a submittal is where, say, the drywall company is saying, these are the materials I want to use. Is this okay for me to install in the project? And I would review it the first time and say, yeah, I think that looks good. That looks like it meets the requirements. But then ultimately the architect reviews it and has to say, yes, this is what should be installed, or no, you guys need to install a different product. So the architect and the construction company work really closely together from the beginning all the way through the end.
So their main thing is helping create the design, and then they're just the person to run any requests or like checking in on stuff.
Yeah, they make the design, and then as the project's being built, they keep an eye on the project to make sure that what they designed is what's getting installed. And if there's any questions or problems that come up during construction, then they help with figuring out what the solution should be and what the ultimate design should be.
Gotcha. Yeah, that's pretty interesting. I remember my brother saying he was interested in architecture, so I'll tell him a little bit about that. That's cool. Also, guys, Bethany S loves to build with Legos and in Minecraft, and she loves architecture too. So Bethany, if you ever go into civil engineering, you'll also be helping design buildings, and being the person you run things by. Emily R says, I'm probably going to be an architect or an engineer. Yeah, that's pretty cool how you get to like design buildings. Like some architects like to focus on like the art of designing things and make things look fancy and things like that. Like sometimes within constructing things, I've noticed that some architects like to add like art into it, which is pretty cool, like making oh, by the way, guys, I see that a few of you are eating your marshmallows. We need that for the activity. So if you need to, shove them aside for a minute. Let's try to get away from those marshmallows for a minute. And so I think we spent enough time on this slide. So let's click over to the filled in one and just kind of review it. And if any of you don't have the workbook, this will be posted on the Facebook page. If you don't have the Facebook, if you aren't on the Facebook group, your parents can email me. But so what does a civil engineer do? They solve problems using their knowledge of physical and natural environments to develop solutions, and they design ways to turn raw materials into valuable products. That's a typo. But well, they design not the raw materials into valuable products. That's actually chemical engineering, a little goof in technology with creating the workbook, but they do with what Nicole works in, sometimes they design the buildings that will be built. They design it, they can also construct it, they can do other things. But what can a civil engineer create? They design and build man-made and naturally built structures like buildings, bridges, roads, canals, dams, airports, sewage system, pipelines, railways, etc. There's many more than this, but this is a big list already. So very wide variety of things that civil engineers can build. And what specific things do they know about? Well, they survey the land and water to build on the earth to make sure that what they're building on won't end up making their building sink in or won't collapse in, like if you're like building your basement, that the ground won't collapse in onto the basement. So they survey the land to make sure it's a good area to build on. And they survey the water to make sure it's drinkable and stuff like that so people don't get sick. They also use materials like concrete, steel, timber, etc. Wide variety of materials that they use to build things. And they know about construction, how to construct things and keep the construction going and things like that. So this is the review page. Again, it'll be on the Facebook group. If you aren't on it, I will have it emailed to you if you request it. But yeah, so on to the next thing. So we just discussed that. Now I'd like to introduce you to Kylie, who will be hosting this activity. I'm going to introduce her a little bit while she gets her setup ready. But Kylie is a senior in high school and is in her final year of Girl Scouts. She is also currently working on her Gold Award, where she hopes to empower girls to be capable and confident in maintaining their cars. So she'll be helping them maintain their cars with like fixing a spare tire, checking the gauges on your dashboard, stuff like that, which is really cool because some women never get to learn that. So I'm glad she's doing this Gold Award. She has been working with her dad to rebuild her engine, and her project is called Girls Under the Hood, girls with a Z. So I thought that was really cool. I'd like to see her finished project with her Gold Award because I think it's really great that she's empowering women to maintain their cars, because sometimes you may think that only men can do that, but women can do anything a man can do. We're here to empower you about engineering, and Kylie's there to empower women to maintain their cars. So Kylie, are you ready to start the activity?
Yeah.
Okay, so I will share the like the picture of the like identify the problem and supplies so that they can pull out the right things, and then I will take it away when after you've stated the supplies and stuff.
Okay. So, okay, let me make sure it's flipped. I have it put up on my computer too. Okay. So first, our supplies. Can you hear me?
Yes, I can hear you. I'm just trying
Okay.
to spotlight you. There you go.
Okay. So first, we're gonna need our toothpicks, and then we're gonna need our mini marshmallows. So make sure you have all of those things out. And then next, we want to decide what kind of base we want to use. So I have
Identify the problem, and then make sure tell them about identifying the problem, and then I'll take away this so you can show them everything else.
Okay. So we want to build a tower using marshmallows and toothpicks as tall and as strong as we can. So you want to make sure that you can choose the strongest thing to make it the tallest and make sure it can stand up.
Okay, I'll stop sharing, and then you can bring them through the step-by-step.
Okay. So first, like I said, there's multiple different bases you can use. So just some ideas. We have a hexagon, a pentagon, a triangle, and a square. So for mine, I'm gonna choose to use the triangle for mine, but we're gonna try different shapes. So what you wanna do to see how sturdy each of them are, you're gonna wanna start by building it 1 story high. So by doing that, you're just gonna add toothpicks and marshmallows to the bases that you've already created.
Yeah, what Kylie's doing right now is bringing you guys through the explore your possibilities step in the engineering process. We haven't done that yet this week, so this is the first time we're doing it, but you're just exploring different possibilities with different shapes, and then you're gonna see which one's the strongest and move on from there when building your tower.
So first I have my triangle tower built. So just to see how strong that one is. And then I'm going to compare it to building a square to see which one I want to build my tower out of. Okay, so now I have my 2 that I'm choosing from to see which one I want to build out of. I'm going to see which ones I think is more sturdy, and then I'm going to continue to add layers on to see how high we can make our tower go. So you choose whatever base you want to use and continue to build onto that.
So to stick the layers together, you use the marshmallows to keep them together, like she's showing you right now. Here, bring it closer to the camera, like pull it up a bit. So she's using the marshmallows as joints to kind of let them connect at the corners, but she's doing it like that. But while you guys are building your 1 layer high structures and testing them out, raise your hand, and when you are finished, lower it so we know when to move on to the building process after we've explored our possibilities. Also, Kylie, while they're working on their steps, someone asked, could you please repeat the step? You were glitching for me. So just repeat the building 1 layer high thing.
Oh yeah. So you want to just take you want to take whatever base you choose and you want to just add the marshmallows so that we're building one structure high so we can see which tower or what base we think is more sturdy to continue to build our tower. So the triangle, you're just going to add 3 more toothpicks at the top and then connect it with another triangle on top. And then for the square, you're just going to add 4 and connect it with another square on top. So then once you have your thing built 1 story high, choose whatever one you want to continue with and build your tower.
Again, if there's any specific issues you're having with this step, just let us know and we can help you figure it out. But yeah, lower your hand when you're ready for the next step to be explained. Someone would like you to repeat the step one more time for the building 1 layer high and testing it out.
Okay, so I'll just show you again. So for the triangle, for example, you're going to start with 3 toothpicks, and then you're going to want to stick the marshmallows on. So then we have a V, and then add 2 more marshmallows. And now we have a triangle. And then for the square, you want to take 4. You want to put them together in the shape of a square. So then once we have our 2 bases, we want to build up. And then, so by doing that, you're just going to stick them. So then we have our triangle, and then you just want to repeat the same thing with testing out the square, just adding the toothpicks and the marshmallows to build it up.
So once you finish off building that, could you show them an example of you testing out one of them so they know what to look for and stuff?
Yeah. So, for example, here I have a triangle one that's built up a couple layers. You can see that. And you can see that it's not the sturdiest thing and it keeps falling over. So you just want to try and make it the strongest thing you can. Not saying that the triangle one isn't going to work. You're just going to have to find a way to recreate it and add more supports to it so that it has a more sturdy base to stand up.
So for the people who have their hands up because they're finishing this activity, just know that when you're like testing out your different shapes, you can always just, if you can't figure out which one's stronger, you can always just build up with one, see how that goes, and then build up with the next and see if that was an improvement with the different shapes. So just kind of either figure out which one is stronger by testing it out, or if you can't find the difference in strength, you can just try out one, and if you think it needs improvement, then either add supports or try the next shape. So with that, you can either lower your hand, move on to the next step, or finish a little bit more testing before we move on. So still 2 more hands up. Again, if you guys have any specific issues you're having since like on the step that you're on right now, you can let us know in the chat if we can help at all. If not, just remember to lower it when you are finished with the step. There's one more hand up, so we're almost there. So if your hand is up right now, if you have a specific issue you're having, or if you don't understand the instructions, we can state them again or try to help you with the issue. And then remember to lower your hand when you are ready to move on. So just for time's sake, I'm going to move on in a few moments. So how about I give it one more minute and then we'll move on to the next step so we don't run over too much. Okay, let's move on to the next step for time's sake. Again, if you are still stuck on yours, but you for any reason can't move on, just follow along and you can join the help desk this evening where I can give you personalized help for the challenge and activity.
Okay, so now that we have our tower, whatever shape you chose, now you just want to go through and see where it's collapsing and where it's falling, and you just want to go and add more supports so that it makes it stronger. So you can add supports wherever you think they may be needed.
So for those of you who aren't ready to move on to the next step, which most likely is most of you, just raise your hand and lower it when you're ready. Also, if you're noticing that while you're building up, it starts collapsing or buckling at a certain point, you can just mark that down. And when you do your improvements later for a challenge, if you were to add more supports in a certain way or change your shape, you can mark where it collapses at this point. And when you improve it, you can see if it improves with height and stability. So again, raise your hand while you're still building up. And when you start to notice where you can't go any further with building up, lower your hand, because after you figure that out, this is your control and you finished building your control. And we can save the improvements and the building higher for later. So raise your hand right now while you're still building it, and lower it when you've hit a stopping point for creating your control. Or if you've run out of marshmallows and toothpicks, you've hit your material limit. So if you've hit either your material limit or your height limit, then let us know. But none of you have your hand raised. So again, raise them while you're still working on it, and then lower them when you are finished with this step so we can move on to our college presentation. So raise your hand if you're still working on it, and then lower it when you're ready to move on after finishing like building your control. So Nicole, while they're working on this step, what types of like with this being their figuring out what types of materials work better, this is kind of their testing out process and like the start off of the whole building process. How does this connect with like real world planning and getting ready for builds and stuff?
So for in the real world, a lot of times when projects are starting off, like if there's a building project that's being designed, the structural engineer might be going through to try and figure out what the building makes sense to be made out of steel, or would concrete be a better structure? So they could use the computer models, the 3D models that I talked about earlier, where they could draw out what they think they want to use and do different calculations to see what amount of steel would they need or what amount of concrete they would need. And then like the construction company could help with figuring out costs to see like depending on the current price of steel or concrete, and figure out what would be the best option to move forward with for the structure of the building. So kind of like what you guys are doing, if you have a really strong structure, but it uses tons of materials, there might be ways that you can modify it to make your structure a little bit lighter, but be also just as strong. So different shapes, like I think the triangle shape that Kaylee's been using looks like that's going to be pretty strong. And as you make modifications along the way, you can maybe reduce the weight of it, but keep it just as strong. But that's the type of thing that a structural engineer would be doing in the real world.
So I'll give you guys about 2 to 3 more minutes to finish your like control before you start improving this evening as a challenge, but I'll give you a few more minutes and then we'll move on to our college presentation. So Kylie, do you want to show them different like finished products that you've made so that they can see different ideas for theirs?
Yeah, so here's one, which is the one I just built. And then here's another one, which as you can tell, there's a lot more going on in this one. And there's a lot more supports and everything. So you kind of just got to play around and see which works best. And if the first shape you chose doesn't work, then move on and try a different shape when you start your rebuilding process.
Okay, so let's move on. Everybody, I'll lower your hands really quick. Okay, so let's move on to our college presentation. So I'll introduce you guys to her. So Carly Huntermark is our college civil engineer that we have, and she is a project engineer for the construction company called Consigli Construction in Massachusetts. She recently graduated from, I do not know how to pronounce that. Rensselaer Polytechnic Institute with a bachelor's of science in civil engineering. She concentrated in structural engineering with a minor of economics. She has worked on a couple of major construction projects, including a middle school and a 55-year-old and up community and a lab building. So over to Carly for her presentation or chat or whatever.
Yeah, I'll be doing a presentation. So let me share my screen. Can you guys see everything?
Yep.
Awesome. Okay, so again, my name is Carly. I studied civil engineering and I'm on the construction side of things. But first, I'm going to take you back to when I was in high school, which wasn't too long ago. So I was actually lucky enough to have a project lead the way in my high school as well. So I was able to take a couple of different classes on many different types of engineering. So on the left, you can see kind of some different things with doing AutoCAD, which is kind of a 3D modeling system. So this one was kind of making a train car. And then I also have done physical stuff, which is more mechanical and robotics, which you can see in the middle. And then on the right, we actually had a civil engineering and architecture course that we actually had as well. So this is actually one of the houses that I planned and built in a 3D modeling system for one of my teachers, actually. And so now going into college, this kind of made me, guess what I really wanted to do. So I decided that I went in undeclared, so I didn't really know, but I knew I wanted to do engineering. And then I was able to finally get into civil engineering from both high school, doing that class, as well as talking with some of the professors and faculty that are on there. And then within that, I just graduated this past May with a structural engineering degree. And just some other cool stuff that I did at RPI that's kind of really fun was crew. So we did rowing out on the lake. I was a part of the Society of Women Engineers. And then I was actually an RA, so I was helping out with the dorms and stuff as well over at RPI, which was kind of cool. And another fun fact is I'm actually a double engineer, is what we call it, because our mascot at RPI is an engineer, and I also graduated with an engineering degree, so that's kind of a fun tidbit. So again, while I was at school, there are 4 major types of civil engineering that we were studying at RPI, kind of just what Nicole also was kind of going over a little bit. So structural, geotechnical, environmental, and transportation. So part of our classes that we had to take at least one class in each of these to kind of get a background in each of them. So I ended up going with structural, which you can see on the bottom left-hand kind of photo, just kind of doing all that kind of stuff. There's transportation was also really fun. That was a lot more of the bridges and highways and the like. And then geotech was really fun. We got to do a bunch of labs with it. So we got to do a bunch of tests at different, test the strength of the soil, how the soil was made up, and everything like that. And then environmental, we actually, my school is right on top, next to a lake. So we actually got to do some testing in terms of water content and pollution and stuff in there, which was kind of really interesting. Now, what was kind of interesting, what you guys kind of touched upon in your kind of project that you were doing is triangles. You kind of don't notice it at first, but I promise you, if you go out and look around at buildings and everything, you can see triangles everywhere. And the kind of main purpose of this is that it's the strongest shape. You would, in order to, and the reason for this is because a triangle actually, you'd have to modify it with the angles, and therefore it wouldn't become a different triangle than what it was. So when you're actually building it, it's the strongest because it stays the same, because if you were to change it, it would change the whole shape itself. So even as you can see on the right kind of hand picture over here, there's the main triangle that you would see in kind of like a house construction. And then on the left, you can actually see that there's giant triangles on the side of the bridge, but there's also within the actual beam, there's a bunch of triangles too. So this actually helps with weight and strength at the same time. And then going off of college stuff, we actually had to do a giant capstone project is what we call it. So it's basically one entire half a year course that goes over everything that you have learned at school, and you had to build a building and design a building from start to finish. So this one was actually my group. I was actually the head person for my group, so I kind of oversaw a little bit of everything, which was kind of really cool to see everybody come together. And so our building was roughly 112,000 square feet. It's 28,000 square feet per floor, and we made it so that the first floor is a bunch of different stores that you could have or restaurants. And then on the upper 3 floors, it was 3 and 4 bedroom apartments for families that could live in. And what made ours really, really cool is that we actually took out the center of the building. So if you see in the bottom left, it kind of shows it. There's basically an empty space right in the middle. So it's almost like 4 buildings connecting together to make up one, where there would be like a park and stuff right in the middle of it, which is kind of cool. So a little bit more about my capstone and a little bit to kind of get you to see what we kind of do as structural engineers. We have over on the left, this is called a beam or structural floor plan, framing plan, in other words. It kind of shows what beams types are going to go in, how long they are, that's all dimensioned out. So lengths and stuff. And then also like this tells us what kind of steel, how strong the steel is and around that. And then on the upper right, you actually see a wind design pressure diagram. So this is kind of cool. Whenever you look at a building, you actually have to design for different types of loading. So different types of pressures coming from earthquakes, wind, environmental loading. So snow, if you're in a snowy area, you have to account for that, make sure the building can handle it and hold it up. And so this one is actually a wind diagnostics of our building and kind of how if wind was pushing on it, what would end up happening, what members were getting crunched together, which is in compression, or being pulled apart, which is tension. And then the last bit is on the right, bottom right, which is a bunch of the foundation and stuff. So either you have basements or you have basically that ground floor, whatever house you're on that's next to the soil, that basically comes down as concrete and rebar that forms it and helps hold it up and keep it in place around the soil. So help design that as well in terms of like thickness of slab, what type of concrete we would want to use, and how much the foundation, what kind of foundation system we want it to do. So that was kind of really cool. Now this kind of leads me into what I do actually today. So I work with Consigli Construction. I'm a project engineer. 3 of the major projects that I've worked on or am currently working on, you can see kind of over here. So the first one that I'm currently working on is 180 City Point. So it's a lab and office building. It's on the top photo here on the right. It's really kind of cool. You get to see a bunch of glass. It's a whole glass wall. There's a garage with a bunch of fancy fins to make it look really nice. And it would be really cool. It actually has a basketball court in it too, which is kind of impressive for an office building. The next one is the Fuller Middle School project. So that was over in Framingham. That's the bottom right, actually. They're just finishing that up now. And basically they wanted to build a whole brand new high school, or middle school, I'm sorry. And basically this one was really cool because there's actually no right angle, so 90 degrees without the entire building. It actually almost looks like a football shape from above if you're looking down from like a bird's eye view, which is kind of cool. And then the most recent one was Willows at Medway that actually just got finished up, and people are living in it now, which is a 55 and up community, and it even has memory care. This is the bottom left-hand photo. So it's really massive, it's really big, it has a bunch of cool stuff in it. There's a pool, there's a bunch of restaurants and banks and hair salons and nail places. So really, really cool. And so that kind of brings me to what I'm doing today. So currently over at the 180 City Point, like I said, and right now we're doing a bunch of earthwork. So what I kind of look at every day is some construction equipment. So not sure how many of these you guys actually know or have even seen, but when people think of construction, this is what they think of. This is what they think of when civil engineering, right? You think of some big yellow equipment, some bulldozers, maybe some excavators moving dirt around. They each have their own purpose and kind of do their own thing to help with the process. And also you can see the cranes, which everyone loves going and seeing those stuff when they start bringing up steel and starting to weld things together. But these are kind of what I see on a normal day-to-day basis. This brings me to what I have to wear. So I'm on site every day, so that I'm actually on the construction site. The building that we're building is like 250 feet to my left. So what I wear to work, I have to wear kind of construction boots all day. I got to wear a hard hat, safety vest, some glasses, some gloves, making sure that I'm on site and getting to be kind of real fun. So not typically what I would think a normal person would think of when they come of engineer, but this is what I wear every day. You can actually see the safety vest that I'm still wearing on from just coming off the site. And so this actually brings a little bit into surveying, which I know Nicole kind of brushed up upon a little bit, but we actually see this all the time on our site. So we have a bunch of surveyors come out throughout our project without the building process. And what they really do is help make sure elevations of the building, so how tall or how high the floors are, the steel is the correct height. They come out and make sure that that's all set. They also help set column lines, which actually help us build the process for the building itself. So we have lines that we kind of put on the building and dimension them out and kind of build the building off that. So everything runs smoothly and everything is built the proper way. The bottom right hand photo, you can see at the bottom photo, that's just kind of a typical surveying kind of equipment that you would normally see. A survey gun, wooden tripod that holds up the survey gun to help kind of blast the laser, and they get to see the elevation that you're at, and then data collection. So I was actually lucky enough to do this in high school too. We had surveying equipment and was able to kind of fiddle around with doing surveying, which was really cool. Then something really cool about my project that I'm working on right now is we're actually blasting. So what that means is we get a bunch of dynamite like you would see, and we kind of blow up the rock because there's not dirt there, and we need the elevations to be certain heights for the building to work. So we actually do blasting. So I'm going to show this video. It's kind of cool. But basically, there's a bunch of mats on it, and it gets blown up. We usually have about 2 or 3 blasts a day that kind of help do that. I'll show it again real quick. So these mats right on top, you'll see the black stuff. It's actually cut up tires that are kind of strung together in mats that are kind of cool. And they help so that no debris or rocks go flying everywhere, because you see there's a highway in the background, there's some buildings on either side, so we want to make sure people are safe, so we don't want it going everywhere. So just show one more time, kind of really cool. You got to see the big blast. It makes a huge vibration and a pretty loud bang too, because we're blasting into rock, which is kind of cool. And then, so that brings me to some of the stuff at my daily tasks for the day. So being a project engineer, I don't actually design anything. I kind of help make sure that the subcontractors or the people building the buildings actually have enough information so that they can build the buildings, and what materials they use are up to par per the designer's expectations and requirements. So I deal a lot with requesting for information, or what we call RFIs. So these are just questions about the designing of the building. If something isn't dimensioned properly, so if they don't know where to place it in the building, that will come up. Or even if some materials, if they want to substitute a material for something else, that might also be in there as well. The next bit that I do is submittals. So this is when, before even any product or material, so like steel or timber, or even something as small as like a refrigerator comes on site, they need to put in paperwork and make sure that the designer or the architect checks off, or the owner of the building, whoever it may be, checks off to say, yep, that's the material that I want. That's what I really, really want. And so then the last bit that I do is material delivery. So checking the material that's delivered on site, what was actually kind of submitted on. So what they're actually said, yep, the architect said okay to, that's what we're actually getting on site. So this bottom photo is actually something that we just did the other day with concrete pouring. So to make sure that the concrete is up to snuff, we actually do a bunch of different tests to make sure that it's within the requirements so that the building is structurally stable for our foundation. So I do that. I'll check the steel when it comes in to make sure that we got the right beams or columns that we need. And everything small and in between that kind of comes across the site. That's kind of my job, to make sure that everything that we get is what we submitted on. And then with that, I'm gonna leave it up to any questions for you guys. Do you guys have any?
There was one back from when you were talking about like either wind or testing that. What does PSF mean or stand for?
Oh yeah, so that's let me pull back. Oh yeah, so PSF, this is pounds per square foot. So basically it's just a terms of measurement. So, you know, you weigh a certain amount of pounds. So we take that and we apply it to the wall. So, and to break that up, we do it per square foot of the wall. So we just want to make sure that the entire wall is getting different pressures. As you can see kind of on the left, you go from a 13.3 to a 17.7. So different parts of the wall gets more pressure than the other bit.
Does anybody else have any more questions for her? Well, we have her right here. Or want to comment on your favorite part of her presentation? Someone just said, whoa, she is cool. Someone else during it said, now that's going to help us with our marshmallow towers when you're talking about triangles.
Oh, yeah.
Anybody else have any questions for her? Or, well, so what advice would you give someone going into civil engineering?
I would say don't take no for an answer. You know, I went to a school where there was I had 150 kids graduate with me, and only about 20 of them were women, but even though that was really small numbers in women, it was kind of cool because we got to really get to know each other really well, because we kind of stuck it out together and really helped each other out. And we actually held our own against the boys, which was kind of nice. So I think in terms of that, you know, stick with the math and stick with doing that kind of stuff. Stick it out if you like it.
Mara said, do you have any friends at your work?
Oh, yeah. I have a bunch of them. Actually, my team that I'm working on right now, so we actually have different teams depending on the project. So I've had 2 teams already, and I'm on my 3rd team right now. Actually, this is the first time that I got another woman who's on my team, which is kind of nice. So we get to smash talk the boys a little bit, which is nice, and keep them on their toes. But yeah, so there's a bunch of people. I work with about 8 different people right now. We're all really friendly. We all, you know, go out after work and kind of hang out and get to know each other and talk about the project, which is kind of cool.
Yeah, it is really cool. Someone else, where'd it go? Oh, someone has their hand up. What is their question? What's your hand up for? But oh, how hard is it being a civil engineer?
Yeah, being a civil engineer, being the only one, civil engineering is definitely not, it's any engineering part. I wouldn't say that one is harder than another. They all have their challenges. But if you really like it, then it makes it a little bit easier because you're more willing to ask questions and you're more willing to not take no for an answer. You're always kind of curious about things and how they work. So for me, a lot of my time right now is time management and making sure that, hey, I have enough time throughout the day to get all of the stuff that I need to get done, while making sure the project's on schedule. So it's kind of, you know, you just got to stick with it, but it's really not overly complicated, but I won't say it's easy walk at the park. You definitely have to study hard and put your time in and effort in.
Bouncing off that, someone asked, what has been your hardest part of your career?
The hardest part, I would say, is probably right now, because I just graduated from school. Even though you learn a lot in school, there's a lot more that you actually learn when you're out of school. So until you're about, like, I would say even like 35 or 40 is when you kind of maybe got a good handle of what you really know when you're in the industry or even in any engineering. And so when the hardest part is kind of not knowing and not being able to have the answers, but you also have to be willing to ask the questions and get the information and try to absorb as much information as you can so that you can bring it to your next job.
Yeah, bouncing off of that from the what's it called? The pledge we've been going out throughout the week. Guys, don't feel scared to ask questions, because the more questions you ask, the more you learn and the more you can bring with you throughout life. And someone says, where are you working now? If not where, then what are you working on the current project?
Yeah, so I'm working on, actually, I can pull up a photo. Let me share my screen so you guys can get a good sense of what I'm working on right now. Let's see. Okay, so can you guys see my screen?
Yep.
So this is actually what I'm working on right now. So this is what our site actually looks like about a week ago, which is kind of cool. You get to see all the kind of rock everywhere. So it's super hard rock that we're kind of drilling into and doing stuff. So I'm working in Massachusetts up by Boston, really close to Boston, if you guys know where that is. And it's kind of really cool. This is where all the blasting is. So that giant blast that we kind of saw, those are the maps right there, down there. You got a nice kind of little excavator down here too that's doing some work and stuff like that. So this is what I'm working on right now. So it's really in the very beginning stages, like not even, we're digging down so that we can actually build the building. But we're on a job for about 2 years. We're going to be done in about 2023. So that should be cool. Get to see it start to finish.
That's really cool. So you're in the step of getting the land ready for the actual building that you're putting there.
Yep.
So guys, any other questions or comments before we move on? Oh, someone just put right now. That's cool. Yeah, it is. She gets to watch things get blown up and dig into the dirt. Just get down and dirty, getting ready for these buildings to be built.
Exactly. Get my hands dirty.
Yeah, I like hands-on jobs. Again, I hope I get something that's hands-on instead of sitting at a desk.
Yeah, I'd probably spend maybe like a couple hours on my desk every day. Otherwise than that, I'm on site talking to different people, getting information that I need on site. So it's kind of cool.
Yeah, it's very cool. So thank you for presenting. It was a really cool presentation. And it was cool how we got to see the site that you're working on right now. But everybody, thank Carly and also thank Nicole for both of their presentations, because I thought they were both amazing and gave us a good view on the different types of civil engineering and the parts of civil engineering that they're working on currently, like construction and like watching the construction, being more into the designing part of it. But yeah, I thought both of these presentations were amazing. One second, I'm trying to pull something up. But let's move back over to the challenge. So Kylie and me can explain that to you before we bump you guys off to the challenge, but let's pull that up really quick. We'll show you guys a video first of it that we have made for you that will be on the Facebook group, or if you're not on it, we can have it sent to you. I don't see the video right now. Here it is. Let us know if you can hear it when we press play.
Supplies your new popsicle sticks, hot glue sticks, a bowl of ice water, and a hot glue gun. Now you're going to take 9 popsicle sticks and glue them together long ways, just like this. Now that you have that glued together, repeat that 3 more times. Now we're going to add triangular supports to our main supports so that we can form two-sided walls. You want to build Now repeat that with your other 2 supports. Now to build the triangle supports to connect the 2 side walls. You just want to place triangles just like this all the way down. Continue gluing all the way to the end. Now flip your bridge over so that we can add supports across this way. Continue gluing all the way down just like this. now, test out your bridge and add supports where they're needed so that it can hold more weight.
So that was the bridge you'll be building. I remember seeing that bridge in Carly's presentation. Carly, do you know which type of truss that, like what type of truss that is for that bridge?
Yeah, that looks like a Pratt truss.
Pratt truss?
Yep.
That's cool. There's many different types of trusses, but the reason we're choosing this type is because it has a flat top. Oh wait, is it? Okay, so the reason we're choosing this type of bridge is because it has a flat top and bottom, so you can like put books on top of it so that they don't fall over, because we're testing out the weight of it to see how much weight it can hold. So you're just going to build the one step by step that we gave you, and then that will be your control, like the start of it, and you will see where it needs to be improved, if it needs to be improved, how to improve it, and then if you want to, then post on the Facebook page and mark improvements that you've added and show us how much weight you can put on top of it. I've seen people put like a bunch of textbooks on top of it, like 5 or 6, but if you improve it, maybe you can double that or triple it. But yeah, that's the bridge that you'll be building. The instructions and the video will be on the Facebook group, but let's pull up the instructions and go over them really quickly just to kind of give you a little rundown of it. Pulling up really quickly. Can you post the link? The link will be in the Facebook guides. It will be on Facebook really soon. But yeah, let me see if I can grab that link really quickly. Oh, so that link is the one that has a typo in it, but we have another video for you that we'll be posting on the Facebook group. But yeah, it will be there for you. So for this one, we want you to build a bridge using popsicle sticks from your materials. We're going to build a certain type of bridge that you are going to test out and find where it needs additional support to improve its weight, but we chose the certain one so you can put weights on top of it really easily because it's a flat surface on top. But the supplies you'll need are popsicle sticks, hot glue, a hot glue gun, lots of hot glue, masking tape, a bunch of rubber bands, heavy items to put on top of your bridge to test its strength, and 2 level even surfaces to span the bridge on. So it's like 2 tables right here to put the bridge in the middle of it. So how about Kylie, how about you bring them through a little bit of a rundown for the popsicle stick bridge?
Okay, so what you're gonna want, oops, hold on one second. So working now. Okay. So what you're gonna wanna do is get out your materials, which Ruby already said were the popsicle sticks and your hot glue gun. And make sure you have something close by that if you burn yourself, you can use it to cool your finger off. So first we're gonna wanna start with making the sides of our bridge. So I already have some done, but I'll walk you through. So we're just gonna take 9 popsicle sticks and we're gonna glue them together by the ends, just like this.
By the way, we're just giving you guys a rundown of it really quickly. So you guys can do this later on your own, but she's just showing you a few things so that you kind of get a little start on what you should be doing later on.
So you just want to glue all of them together, 9, and you want to end up with 4 sides, just like this one. So you want to end up with 4 of these. And then after you have all of those glued together, you're going to want to take the popsicle sticks And you're going to want to create triangles so that we can connect our two sides together. So just like that. And you want to continue that all the way down. And then after we have our triangles done on the side, we're going to want to put triangles across the bottom too to then connect the two sides together. And then once we've done that, we're just going to take popsicle sticks and put them across the top so that we have a flat surface for our books or whatever we want to use the way can sit on.
Yeah, the instructions and the video will both be on the Facebook page. And if you guys have any issues with doing your challenge or doing the activity, then just join the help desk from 5 p.m. to 6 p.m. Eastern Standard Time this evening, and I'll be there to help walk you through it. Thank you, Kylie, for the little rundown of it. Again, the video and pictures will be on the Facebook group. Can you guys see me? Am I big on the screen? Okay, cool. So that was the challenge. Now we are going to move on to doing our Kahoot. Okay, I will start this right now. Okay, Kahoot. Day 4, civil engineering. So civil engineers design solutions for which of the following? I hope my brother will learn that. He keeps grabbing handfuls of marshmallows. Yes, all of the above. They design solutions for structures, environmental things, and transportation. So all of the above. We've got Mara in the lead right now. Which of the following doesn't fit? Yes, space travel does not fit. That goes more with aerospace engineering. Environmental engineering is a part of civil engineering. It branches off of it where they focus on testing land and water. And transportation is also a branch off of civil engineering where they build roads and bridges and stuff like that for transportation. But space travel is not a part of that. Now we've got Arabella in the lead. Mine didn't let me choose for it. Oh no, which of these does not belong? Buildings, roads, bridges, or cars? Yes, cars does not fit in because it's not civil engineering. Roads is the transportation part of civil engineering. They build roads, bridges, buildings, many other things. Possibilities are endless, but cars does not fit into that. They do not build cars. Now Mara is back in the lead. Which of these do not belong? Another one. Oh, what? I guess this is a copy. Well, now you get a second chance. Yes, cars. Florence is now in the lead. Civil engineers are blank. Creative, inventors, problem solvers, or all of the above? Yes, all of the above. They are creative inventors and problem solvers. Florence is still in the lead. True or false, civil engineers are not concerned about gravity when building things. So maybe a trick one. Yeah, I'm not sure if we talked about this fully, but I'll explain it after we answer the question. Yeah, it is false. Wait, they are not considered. Yes, it's false because when they're building buildings, they gotta put gravity into account, because maybe when they build high enough, they might start sinking into the ground or collapse under pressure. So they do think about gravity. It's not your fault if you got it wrong, because we didn't go over this enough. So that's totally fine. But yeah, they do have to take gravity into accountability at some point when building heavy buildings. What is the strongest shape for building? We went over this during the presentations. Yes, triangles. A rhombus is like a tilted square, and a square isn't as strong as a triangle, because a square, it can kind of like fall over sideways and kind of become a rhombus. And a rhombus, it's just not that strong and it might collapse. But a triangle, it's way harder to collapse, and a circle doesn't have any sides, so it'll just kind of bend. But triangles are the strongest shape for building. So here is third place, we've got UJ. Second, we got Gabby B. And in first, we've got Annabelle. And the runners up, we've got Zoe P. and Emily R. Okay. So we just did the Kahoot. Now let's move on to the poll to see how much you guys have learned throughout the week. So here is the poll. I'll launch that. So now, how much do you know about civil engineering? A lot, a bit, not much, or nothing. I would say that my knowledge on civil engineering did go up today. A few people are saying a lot, some are saying a bit. A lot more people are saying a lot, majority are. 3 more people to go. 2 more. I'll end it in a second. So here are the results. We've got a lot of people who know a lot about civil engineering now. Some know a bit, and one person knows not much, but that's totally fine, because again, you can rewatch these recordings. You can, which will have the presentation on it and everything we've learned. You can also look back at your workbook or look at everything on the Facebook page, but it's totally fine if you don't know a lot about civil engineering, because over time you can learn more and more. That is the results. A lot of people did know more after today, so that's really good. So today's challenge is to try to make improvements by thinking like an engineer. So you've already built your control for your toothpick tower, so now you can either improve it or test it out. You can just go as far as you think you can with improvements to see how tall you can build and how strong it can be. Same for the popsicle stick bridge. You're going to build it, test it out, find any improvements you need to make, and then see how much weight it can hold. And again, post your videos and photos on the Facebook group to be put on the prize wheel for the morning for posting on the Facebook group. And if you guys have any issues with the challenge or the activities from today, you can always join me at the help desk tonight at 5 p.m. to 6 p.m. Eastern Standard Time. So the next part of our pledge is to act like an engineer, build things and improve them. Perfect. We'll be doing that this evening for our activities and challenges for improving them and building them. So remember, act like an engineer and build things and improve them. So I'd like to thank Nicole and Carly and Kylie, all of you guys, for helping me with my project. It's been really helpful and I enjoyed all of your presentation. And I also like to thank Chase for being the chat moderator and the prize patrol for today, while also helping me on Monday. It was very, very helpful, and I had fun working with you guys for my project. It's been really helpful. Thank you so much. And I'd also like to thank everyone for coming, campers and parents. Again, if I had nobody to do this camp for, there wouldn't be a camp. So thank you guys for coming to camp today, and I'll see you all tomorrow. See you guys later, and thanks for coming.